Why are activity coefficients used in chemical potential calculations? Imagine you're trying to predict how a mixture of liquids will behave when mixed together. It might seem simple, but real mixtures often behave differently than ideal ones. That's where activity coefficients come into play. They are used in chemical potential calculations to help us understand these differences. Chemical potential is like the energy needed to add one more mole of a substance to a system. It depends on temperature, pressure, and how much of the substance is there. In ideal solutions, molecules interact uniformly, so the chemical potential can be calculated directly from concentration or pressure. But in real mixtures, molecules don't always behave predictably because they interact in complex ways. This is where activity coefficients become useful. They act as correction factors that adjust the concentration or pressure to reflect the actual behavior of molecules in the mixture. Think of activity coefficients as a way to fine-tune our calculations so they match what really happens. When molecules interact strongly or weakly, the activity coefficient accounts for these deviations. By multiplying the concentration by the activity coefficient, we get what is called the activity. The activity better represents how the substance actually behaves in the mixture. Using activities instead of raw concentrations makes calculations of chemical potential more accurate. This is especially important when dealing with solutions that have high concentrations or contain ions, like electrolytes, where interactions are stronger. In thermodynamics, chemical potential guides us in understanding whether a process will happen spontaneously or reach equilibrium. If we ignore activity coefficients, we might predict the wrong direction for a reaction or miss the true point of balance. Using activity coefficients ensures our predictions about spontaneity and equilibrium are reliable. In practical terms, this helps chemists and engineers design better processes. Whether it's figuring out how much salt dissolves in water, how reactions proceed in complex mixtures, or how different phases separate, activity coefficients give us a clearer picture. They allow us to apply thermodynamic principles to real-world systems, not just idealized models. So, in summary, activity coefficients are used in chemical potential calculations because they correct for the non-ideal behavior of molecules in mixtures. They help us understand and predict how substances interact, ensuring our calculations about spontaneity, equilibrium, and phase behavior are accurate. Without them, our models would be too simple and often wrong for real systems.